Okay, good morning, everyone, and welcome to Kaggle Days Tokyo. It's my honor to be with you today and to meet a lot of our Japanese community. You are a really critical part of Kaggle's global community of over 3.5 million data scientists and machine learning engineers. As Rachel mentioned, my name's Ben. I'm Kaggle's co-founder and CTO, and I am here to speak to you today about our plans to take Kaggle competitions to the next level by introducing a new concept, simulation competitions. Simulation competitions will build on our popular machine learning prediction competitions and code competitions that we've created so far. But before I go into our plans here, I want to take a step back and establish context. Context for where we are in the development of humankind, and context for where we are in Kaggle's development. I am about to show you my favorite chart on the history of human development. It'll show human well-being over time as measured by global GDP per capita. For most of human history, human wellness has been roughly flat, where you didn't see generational improvements in human well-being from generation to generation. However, several hundred years ago, something really unique happened. We hit an inflection point driven by the Industrial Revolution, where we suddenly entered an era where human well-being dramatically improved from decade to decade and from generation to generation. And then, over the past 50 years, this trend's dramatically accelerated, really driven by two things, the combination of globalization and then automation from computing technology. Two things could happen from here. We could complete the globalization trend, leveling off per capita GDP at roughly that of developed countries, or we could drive the next inflection point and ongoing acceleration of human well-being through the advancement and wide-scale adoption of AI and machine learning technologies. So, these inflection points don't happen automatically or by accident. They are driven by the creative and talented work from a group of talented individuals like yourselves. We, the group of people in this room, have the unique opportunity to drive the next inflection point. So let's look at where we are in Kaggle's development. Kaggle is about a decade old now, and when we launched nearly a decade ago to run When we launched nearly a decade ago to run supervised machine learning competitions, few production machine learning implementations existed, and machine learning largely existed in the realm of academia. One example of this that captures the state of the research at that time is research involved around standard data sets like the MNIST one that many of you may have trained your first machine learning models on, where users would train models in small benchmark data sets and then share their results over many years or decades in academic publications. There's a huge amount of exploration of possible machine learning approaches, ranging from support vector machines and logistic regression to naive Bayes and quadratic discriminant analysis. Yet there is little awareness among the community for which approaches commonly worked well in practice across different classes and different types of problems. Then we built the standard Kaggle machine learning competitions around this form. And to this form, we also added a couple elements. We added real-time leaderboards and shortened the duration of the competition from years or decades to typically months to really incentivize participation and rapid development, as well as adding community elements like discussion systems and user profiles to help aid in collaboration. Based on this, and since 2010, we've now run 364 public competitions of this form that nearly 500,000 of our users have made submissions to. And by providing these competitions with a consistent evaluation criteria and holdout set, our public general competitions have really helped demonstrate the state of the art in current machine learning techniques and spread and propagate the techniques that work well. And looking back, we have a lot of examples of this. Back in 2011, we first saw random forest emerge as the dominant algorithm on Kaggle competitions, where many of our users realized that random forest worked well out of the box on a variety of structured data challenges. The next year, in 2012, many of our users started to use another variant of ensemble decision trees, gradient boosted machines, that, at least at the time, were a bit tougher to tune and to get started on, but achieved slightly better results than random forest and created a kind of new standard state-of-the-art methodology. And then in 2013, we saw a team for the first time, Jeff Hinton's PhD students, win a Kaggle competition with deep learning. And this really helped herald in the current era of success of deep learning on a variety of applications. Casting forward to today, we see a continuation of this trend where the combination of gradient boosted machines and structured data problems and deep learning on both structured data as well as more complex image, LiDAR, CT scan, medical imaging, and natural language understanding problems perform at the state of the art across all of our recent competitions. And as we've been running all of these competitions, we've also seen some large barriers that our users experience in trying to apply machine learning. Two of those barriers are it is tough to collaborate on machine learning workflows and share code with others or take code from others and use it in your own work. And also, when you're trying to apply machine learning to a new problem, it is tough to get access to data on that problem. And once you either get access to the data set for the problem or create one yourself, you spend a lot of time cleaning and structuring the data to be high quality. And we've gone and launched 2 new products around these challenges. Kaggle Notebooks, aimed at code collaboration, and Kaggle Datasets, aimed at dramatically increasing your access to high quality data. We built Kaggle Notebooks on top of one of my favorite open source projects, Jupyter, and it gives our users frictionless access to cloud compute. It makes it easy for you to get started on a new problem by, with a click of a button, enabling you to spin up a Python or R notebook environment with the data preloaded into it, as well as making it easy for you to share and work with others by giving everyone the same standardized compute environment through Docker containers so you can reliably reproduce your work and work that others create. And this has led our users to create a really rich library of nearly a 250,000 public notebook examples that cover every piece of machine learning and data science and data visualization and associated techniques that provide a really nice starting point anytime you want to try exploring a new problem or exploring a new data set. Now, looking at Kaggle datasets, we're aiming to solve the challenges you face with access to high quality data. And we want to provide access to other world's public information through a same consistent interface. We make it really easy for you to publish a new dataset in Kaggle through a web UI or an API. And then we encourage data publishers to thoroughly document their dataset, including with metadata around its provenance and where the data came from, as well as detailed descriptions of every file, column, and table in the dataset. We also tightly integrate Kaggle datasets with Kaggle Notebooks and make it so you also get access to all the content and analytics that users have created on top of the dataset and have that alongside the data itself as your starting point for working with it. And this has led our community to publish over 25,000 datasets so far on our platform, ranging from a huge variety of domains such as healthcare and government to sports and video games. We also are continuing to create new functionality to help encourage the creation of high-quality data sets and content on this. For example, just about an hour ago, we launched a new feature you'll see on Kaggle now called Tasks that enable you to specify suggestions for improvements to data sets or work to create on top of data sets. So far, we've talked about our popular prediction competitions, some of the techniques such as gradient boosting machines and various flavors of deep learning architectures they've helped popularize, as well as products that we've built on top of them to solve user pain points that we observed, I want to take a step back and look at the broader impact machine learning has had on society during this time frame. So alongside these developments on Kaggle, the role of machine learning in society has shifted from a handful of researchers exploring techniques that would work well on research datasets to large-scale production applications that reach every internet-connected user on our planet. And here's a couple of my favorite examples amongst thousands. State-of-the-art natural language understanding models such as BERT now are used to improve every web search query that we make. Recommendation systems govern the news that we see. For example, I get news about AI and machine learning, snow conditions in California, and recommendations for a trip to Tokyo. Deep convolutional neural networks will help recognize what's in our photos. And if I want to find some of my favorite meals I've had since I've arrived in Japan, I just have to search my photos for sushi. Machine learning character recognition models and translation models make it easier for different cultures to communicate. And in my case, they also made it easier for me to make my coffee when I was too jet lagged to see the English button on the menu and pulled out a translation system instead. And then healthcare is at an earlier stage relative to a lot of the consumer applications of machine learning and productionization, but we're starting to see some really exciting applications move from pilot or proof of concepts into pilot phases, such as diabetic retinopathy for screening a leading cause of blindness, where they're actually starting to aid medical professionals in their clinical decision making. And this is one example that started with a Kaggle competition as well. So, this productionization of machine learning brings new constraints and considerations beyond simply optimizing machine learning models for predictive accuracy. For example, we care about latency. I may have the best natural language understanding model in the world, but it's going to be useless for me to improve web search if it can't return predictions in tens of milliseconds. We also care about memory usage. The best language translation model in the world will be useless to me if I can't run it on in a mobile device with a small memory footprint that enables me to use it in remote and disconnected settings. We care deeply about fairness. We don't want machine learning models to propagate the current biases that we see in society and our data sets, and instead to serve all people on the planet equally. And finally, we care about model explainability. Especially as machine learning enters mission-critical domains like healthcare with deep implications on people's lives, it's really important to understand not just the prediction a model makes, but why it made that prediction and what is driving that prediction. So with those considerations in mind, we introduced a new type of competition to start targeting these. Code competitions, which builds on top of our prediction competitions, hosted code execution, and reproducible data sets. Code competitions involve submitting code instead of predictions to a competition. This code we then run on our end, which may train and create predictions for machine learning models or evaluate a machine learning model that you submitted on new test data. And over the past several years, we've now run 16 of these competitions with 32,000 of our users submitting to them. One of the early examples we ran was a competition with Quora on detecting toxic content in their online Q&A site to improve the quality of their community. Then one lesson that we've learned from this is for code competitions where processing time is at a premium, we have much simpler models that result from in these than kind of the complex ensemble of models that we see in standard prediction competitions. As another example of this, we ran a code competition focused on classifying over 1,000 different sounds, ranging from cheering crowds to raindrops to dogs barking. For this competition, training could have been done offline, but we required the inference to be done online on Kaggle and limited the total compute to the test set for an hour of GPU usage. And again, we saw that constraining the compute users could use was a highly effective regularizer on model complexity, as we see from the relative simplicity of the winning solutions. And speaking of barking dogs, another example of where we can take competitions like this, we created ourselves. Wendy and Kaggle's team created a challenge you to generate examples of dogs using 9 hours of compute and training from scratch. And these are the results of the best dog images that were generated after 9 hours. In this case, we're getting pretty close to something I might want to adopt. I'm personally pretty partial to the golden retriever type dog in the middle of the top row. So it's still at the very early days for code competitions, and look for us to explore many more types of this competition in the future as we start incorporating more production machine learning constraints and considerations like fairness and model explainability into them. However, it's not predictions alone that are going to really help drive this next inflection point in human well-being. AI algorithms in the real world don't just make predictions, they are interacting in an environment, and the predictions that they make will drive decisions that change their environment. So the next frontier will be optimizing our AI methodologies for how they interact with environments. And we're creating a new concept, simulation competitions, around this next frontier. Like the MNIST digit recognition problem in the early days of machine learning, our first forays here will look very much like toys. The very first competition that we're going to be launching will be like the Titanic competition or digit recognizer competition analog. It'll be help users get started with this concept and be a two-player ConnectX game that you'll be able to start playing with in the coming weeks. Then, like a normal Kaggle competition, you'll still be writing code to solve a challenge and will be ranked on a real-time leaderboard. However, unlike your normal competition, your code will be played many times against other users in simulated environments and scored as a function of how it does in the environment that includes all the other players. And we will very quickly move on from solved, simple, getting started games like ConnectX to more complex and unsolved games in the future. And though our first forays into simulation competitions and first competitions we launch here will look like games and toys, the challenges that we hope to ultimately solve through this are not. Manipulating objects with robotic arms remains incredibly challenging and a relatively unsolved problem, especially when we try extending that to applications like automatically folding laundry. In developed countries, about 2% of the population currently works on agriculture and providing sustenance for the rest of the population. And in both developing countries as well as for most of previous human history, that number has been well above 50%. Improvements here like automated farming equipment and has the potential to reduce these numbers close to 0% going forward, freeing humans from the needing labor to generate the core sustenance for our survival. Another way that we may apply this is thinking through optimizing how humans learn new skills and concepts. Right now, we take a kind of one-size-fits-all to most education and skill learning systems. And wouldn't it be amazing to instead have an AI agent that optimizes for you the information it could be presenting to maximize your ability to learn a new skill with the content and the exercises at precisely the right point in time? We'll also be able to create new forms of creative and interactive entertainment. A really neat early example of this is a game a machine learning engineer created called AI Dungeon 2. That is created based on OpenAI's GP2 transformer model that enables users to interact with freeform text actions in a virtual world. I definitely encourage you to try that out and play it to see both get a glimpse of the future of where entertainment like this may go, as well as see all the limitations in the current state-of-the-art in natural language understanding, where it's clear that we can generate kind of good English text that sounds reasonable, but doesn't make sense in the context of a simulated world. So there's many more kind of as yet untold applications of AI interacting environments that will be created in the future. And I expect these to transform trillion-dollar industries and create new ones. And with the skills that you're learning and techniques that you're creating to work on problems like this and optimize the world with data, you will have a really unique opportunity to create the next inflection point in human well-being. I'm tremendously excited to see what we can build together here. So thank you for coming to Kaggle Days. I hope you enjoy some of the upcoming talks that a lot of our amazing Grandmasters have put together for you, and I really look forward to seeing the AI applications that you create down the road. Thank you.